In this video, we're going to learn how to solve problems where we've been given the mass of one of the reagents or products and we have to determine the mass of another substance that's involved in the chemical reaction. Okay, let's have a look at the first example. In this problem, we've been asked to determine the mass of magnesium oxide that will be produced from 12 grams of magnesium burnt in excess oxygen. You'll notice that I've got a flow chart on the screen. That flow chart we're going to use to solve all of the problems that we do today. However, that flow chart will not be available to you in an exam. So once you've got the hang of using this flow chart, the idea is that you should be able to remember these steps without actually referring to the flow chart. Okay, so as you can see from the flow chart, the first step will involve determining the number of moles of the substance for which we've been given the mass. Okay, so we've been given the mass of magnesium, so we're going to determine the number of moles of magnesium. To do that, we'll use the equation mass over molar mass. Okay, I've worked out the number of moles of magnesium. The next step is to use the equation to determine the number of moles of the substance that we're trying to work out the mass of. Okay, so if we have a look at this equation here, we can see that magnesium and magnesium oxide have the same coefficient in front of them. So what that means is that they react in a 1-to-1 ratio. So therefore, the number of moles of magnesium oxide will be the same as the number of moles of magnesium. The final step is to work out the mass of magnesium oxide by using the equation mass is the number of moles times the molar mass. Okay, just a couple of points to note before we move on to example 2. You'll note that in the question I was given a mass with 3 significant figures, which is why I've given my answers to 3 significant figures. The other thing that's important to keep in mind as well is that whilst I've only written 3 significant figures for each step of the calculation, I've actually stored that value into my calculator, and it's a stored value that I've used for the next step. So we only ever round off at the very end of a calculation in chemistry. So don't round off values at each individual step in your calculator. You can round it off in your working out, but in your calculator you save the number with all of the significant figures, and you only ever round off at the very end of the calculation. Okay, moving on to example 2. This time the reaction is between hydrogen gas and chlorine gas to form hydrochloric acid. And we've been told that 16.30 grams of chlorine is reacting with excess hydrogen, and we need to work out the mass of hydrochloric acid produced. So first step is to write an equation. Okay, you'll notice that the question talks about excess hydrogen. All that means is that we've got plenty of hydrogen to completely react with the chlorine gas. So in other words, we don't need to worry about the amount of hydrogen. It's the number of the number of moles of chlorine that's going to be the limiting factor. That's the one that we need to worry about. The hydrogen, we've got plenty of that. Okay, so in the question, we've been told that we've got 16.3 grams of chlorine. So the first step following our flow chart again is to work out the number of moles of chlorine gas. The next step is to work out from the equation the number of moles of HCl. We can see from the equation that the ratio of Cl2 to HCl is 1:2. So therefore the number of moles of HCl is going to be double the number of moles of chlorine gas. Okay, and the last step will be to work out the mass of hydrochloric acid. Okay, and again, in the question, the mass was given to 4 significant figures. So in my solution, I've written the answer to 4 significant figures. Okay, so in this question, we've been told that magnesium ions are reacting with sodium hydroxide, and we haven't written this type of equation before, so that's why I decided to go through this example with you. So magnesium ions we would write this way. and the magnesium ions are reacting with sodium hydroxide, which is substances in solution to produce magnesium hydroxide. And now we need to balance the equation, so I need to put a 2 here. Okay, this time we've actually been given the number of moles of magnesium, so we can skip step 1. We can go straight to using the equation to work out the ratio in which the substances are, and so work out the number of moles of magnesium oxide. Okay, so the ratio of magnesium to magnesium oxide is 1:1. Which means that since the number of moles of magnesium was 0.05, we've also got 0.05 moles of magnesium hydroxide. And now we just need to work out the mass of magnesium hydroxide. And that works out to be 2.9 grams. In the question, the value given had 2 significant figures, so my solution has 2 significant figures as well. The last example I'm going to go through is question 37. I've selected this example because you'll probably struggle to come up with the equation on your own. Okay, what they've told us in the question is that the copper ore, copper sulfide, is roasted in air. What that means is that it's reacting with oxygen. So that's the equation. Now that the equation's written, the problem is quite straightforward. So we've been told in the question that 1 ton of copper is produced. So the mass of copper is 1 ton. That's the same as 1,000 kilos, which is the same as 1 million grams. We can now work out the number of moles of copper. Then we can go to the equation, and we can work out from the equation that the ratio of copper to sulfur dioxide is 2:1. So that means that the number of moles of sulfur dioxide will be half the number of moles of copper. That works out to be 7,867.8 moles. Okay, now the next step is to work out the mass of sulfur dioxide. Okay, so that works out to be 504,091 grams. Now going back to the question, in the question the mass of copper only had 1 significant figure. So I need to give my answer to 1 significant figure. So that works out to be 500,000 grams, which is the same as 500 kilos, or half a ton. Okay, now what you really need is lots of practice at solving this type of problems, and you've got lots of examples of this type of problem in your OneNote to work through.